But, why don't we give scientists credit in proportion to the amount of effort they put in? Sometimes one comparison I sometimes use is you're looking for something that's been lost. Maybe you're looking, a child is lost in the forest, and you sort of divide up the different areas of the forest and go searching for the child. And some people are looking in the wrong place. Somebody who has the right assignment will come across the child, but we wouldn't say, "That's great, you did such a wonderful job," and then say to everyone else, "Thanks for nothing." We would say, "It's great, everyone contributed, and everyone deserves credit and for a successful outcome." That's not the way that science works. It really is kind of the thanks for nothing. It's like you get the glory for making the discovery, and everyone else who was trying and didn't get there, maybe just through bad luck, because you happen to be trying out a method that wasn't the right method, but nobody couldn't have known. Still, you get nothing. I mean, you get your salary. Maybe you made some incidental discoveries along the way. You get credit for those, but you don't get credit for the big thing.
Michael Strevens is a professor of philosophy at NYU and author of 5 books, the latest of which is The Knowledge Machine: How Irrationality Created Modern Science. His research interests include the nature of explanation, complex systems, probability, some questions about science, the philosophy of science, amongst others. Here we spend a lot of time talking about the nature of explanation, how to move towards a general theory of explanation that stands throughout the sciences. And this opens up some pretty interesting opportunities to address some long-standing questions in the philosophy of science. We talk about how explanatory frameworks develop in science and some of the social structures and motivational structures behind science. This was really, really a fun dive into some of the machinery of how science works. This is my conversation with Michael Strevens. Got it. How did you get interested in the idea of scientific or explanation in the first place?
Well, I started out in life actually interested in the sciences themselves, doing a science degree at university. And when I discovered a kind of an inexorable tendency to make everything as abstract and foundational as possible, I realized I belonged in philosophy, really. But all along, I was thinking about subject matters that are the subject matters of the science. So I wanted to understand how the mind worked, how the mind evolved, how science worked. These are all questions, of course, that are both asking for an explanation, but also where the philosophical answers themselves often turn on subtle matters of explanation. For example, one philosophical idea I got very interested in is the idea that the evolutionary history of representational structures in the mind has something to do with determining the content of those mental states. So what people call teleosemantics is the technical term. But that meant that to sort of think about the nature of thought, you had to think in a kind of a subtle, sophisticated way about the sort of explanation by natural selection that turns up in evolutionary biology. So I feel like I was I was traveling on many roads that looked like they were heading in many directions, but often converging on the topic of explanation, which then became a big one for me in my philosophical career.
So are you trying to build towards a theory of explanation that can stand amongst all the sciences?
Yes, that's what I'm looking for, is a kind of a unified way of understanding what a good explanation consists in, that covers both very detailed causal stories about exactly how something came about, the sort of thing you might tell in a history, say, that at the kind of dynastic level of some empire, and also the very kind of abstract or structural stories that scientists often tell. It's the kind of thing you might get in a sociological story about an empire, where it's the economic forces or geography that is the ultimate determinant of how things turn out. Of course, my role is not to decide whether one or the other of those explanations is correct in any particular case, but to understand what the people who are giving them are really aiming for. So that's spanning a lot. That's spanning, on the one hand, a kind of a blow-by-blow, step-by-step causal history. And on the other hand, some kinds of explanations that almost seem to have no temporal structure at all, in the sense they're saying, well, it was just inevitable that one way or another things would end up this way eventually.
Right. Right. I imagine that's a lot to think the same way through physics all the way up to political.
That's right. And I used the example of the kinds of explanations you might give in history or social science, but you get the same contrast at the level of physics. On the one hand, a kind of the kind of classic Newtonian explanation where one ball hits another ball and imparts it with momentum and so on, and then more kinds of equilibrium explanations where you say, well, I don't really understand the detailed dynamics of the system, but I do know that it just has this one fixed equilibrium. Everything's going to ultimately end up in equilibrium one way or another. Or the kinds of explanations you get in statistical physics, where you are abstracting away from the details of exactly what happens and just thinking in terms of the frequencies of outcomes. So sometimes this happens, or when we look at a gas, we'll see a certain proportion of the molecules will be traveling at the speed and a certain proportion at the speed and so on. And that's enough for us to understand why the gas behaves in certain ways. Why, for example, if you if you sort of spill your perfume at one end of the room, the scent will diffuse at a certain speed down to the other end. You just need that kind of statistical understanding. So it seems like explanations happen at all these different levels of abstraction. Some of them kind of can't get enough causal detail. Some of them are, in principle, ignoring certain kinds of causal detail while focusing on others. And some of them barely seem causal at all. They're not really telling a story. They're just kind of deducing what the ending of the story will have to be. And I wanted to see if there was something that all of those approaches had in common, and whether there was a sort of a criterion, if you like, that would tell you what the right level of abstraction was for any particular explanation. So yes, that's. I think this question comes up to in all of the sciences, from physics all the way up through grand history.
Right. Okay. So to dive into it, at a quick glance, people often think that explanation means to identify the causal relations that are relevant to whatever you're observing. Now imagine that the story is more complicated than that. So you introduce things like the selection criteria or the explanatory relevance criteria. So could you speak to that a little bit?
So the way I set things up is like this. You're trying to capture something about the story, which I think of as a causal thing, as long as we're in the realm of science. Yeah, not everyone would agree with that, but I think I can make allowances for people who are a little bit more suspicious about causality always being at the center of it. But what I think my own work is less about the nature of causality and so on, and more about the selection principle, which is the principle that tells you which bits of the complete story, if you like, the story that includes absolutely every detail, which bits of it are going to make it into the final explanation. Sometimes, as I say, it's going to be so little of the story that you won't really have much of an idea of how the story unfolded, except that it had to end in this particular way, with the gas being completely diffused through the room, with one particular variant kind of taking over the population, the fittest variant taking over the population one way or another, and so on. I could talk a lot more about the selection principle if you like, but maybe you want to zero in some specific aspect of it, or just describe its general nature.
I think describe its general nature, and then I guess we can go from there.
Sure. Okay. So this is jumping into the kind of the philosophical machinery that's at work here. I think what we want to do is look at the complete causal story, uh, uh, and frame our explanatory question in enough detail so we have a definite conception of the thing that we want to have explained. Are we interested in just in whether um, the the dark colored moths take over the population, or are we also asking why it took a certain amount of time for them to take over the population? So a little bit more information. So get an idea of exactly what you're after, informationally speaking. That is what it is that you want to have explained. Um, and then uh, and then take that story and ask yourself which bits of the story are essential just for seeing that particular thing was going to happen. So just the bits of the story that imply that the dark moths would take over, or just the bits of the story that you need, which would be a little bit more of the story probably, to see why they took over so quickly. Uh, 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 the more detailed the question you ask, often the more detailed the story you have to tell. Not always. In some amazing cases, a rather detailed question will get an answer that really only has to point to a few high level aspects of the situation. But that's the basic idea. A lot of the philosophical work that's really sort of now getting into the page by page development of the principle and sort of saying what it really means for some aspect of the story to be essential to seeing that such and such a thing was going to happen. And I try to do it in the simplest way possible, I think, by just using the resources of deductive logic. So if you just wrote down some aspects of the story, how much would you have to write down in order to be able to deduce that the thing you're trying to explain would happen? At least that's for cases where the story is deterministic in the first place. When it's all statistical all the way down, it'll have to work a little bit differently from that. But in the same spirit, maybe deduce a high probability depending on exactly what's going on. But there's the idea. It's kind of, you can really just use the in a way what is the most simplest, although also in some ways the most uncompromising tool in the philosopher's toolbox, deductive logic, to say what it is that really matters about a causal story for the purpose of explanatory understanding.
Right. That makes sense. I mean, even if it's a probabilistic scenario, you can still narrow your parameters based on some sort of selection criteria, right? You still don't have to look at everything.
Yeah, so when it's really not deterministic, then what happened didn't have to happen, but it had a certain probability of happening. And I think what's relevant to explaining why it happened is everything that had a positive impact on that probability. So in the end, of course, you might be in a situation where something very unusual happened, a really unfortunate chain of events that um, um, didn't really have to end up as badly as they did. But and so what you're doing is saying, well, it's not as if I can show you that given the way the world was, you were doomed. The glass had to slip out of your hand in just such a way that it tumbled and hit the sharp edge. Maybe I should say the phone, the sharp edge of the cabinet. There was a certain probability to that, but I can tell you everything that was relevant to what's happening. Your hand was a little bit slippery. The the sharp edge of the table was pretty sharp and made out of a pretty hard substance, that sort of thing. And even though 9 times out of 10 it would have been okay, and it was just bad luck that it wasn't this okay, these are the things that did in fact matter. So it's the same kind of thing, except you're looking for the elements of the story that had a positive impact on the probability that made the event more likely to occur.
Right. So when you're situating explanation, then in all of the sciences, how do we deal with the problem of reduction? So does analysis at one level, say something to do with psychology, need to have an understanding of the analysis at the bottom level? Like, is there explanatory independence at each level, and is that explanatory independence related to the selection criteria?
Yeah. Um, yes, definitely, to all of those questions. So I think, although a lot of people disagree with me that to really fully understand something, you have to appreciate the roots of the processes at work in fundamental physics. Now, that doesn't mean you have to know the complete fundamental physical story. At least I hope not, because we almost never have that. So it would be completely bereft of understanding if that were necessary. But often what you just need is some kind of very high level appreciation of the fundamental physics, if that makes sense. That so you don't need, for example, in the case of the understanding the behavior of gases, you don't need to follow the trajectory of every molecule. But I do think you need that you understand better if you have some appreciation of why molecules bounce off one another. You know, what the forces at work are that are responsible for that. Now, some people would say, no, you don't need that. You can kind of fully understand what's going on if you just know that there's some, I mean, you have to know that they bounce off one another. So that's, I think we all agree on that. But you don't need to understand the underlying mechanism. You can fully understand what's going on. And it's certainly true that scientific understanding often takes that form, partly because sometimes you just don't know what the mechanism is, but also often because there's a lot of division of labor in the scientific enterprise. So I one at even again within domains. So a physicist who works on certain aspects of statistical physics might not have a very good grasp of the precise quantum mechanical reasons that things bounce off one another, or certainly they're not going to spend a lot of time thinking about that because their job is not to worry about that, but to do something else at a different level. Meanwhile, there's some other physicist who's supposed to be worrying about that. So I think the actual form that explanatory understanding takes in the sciences is a form where at one level, somebody just specializes in a certain compartment and they black box the stuff around that compartment, but also the underlying workings, the physics of collisions, and somebody else is supposed to come in and figure that out. Maybe they haven't figured it out yet. But I do think in principle, and here it's really important to say in principle, that our understanding of the way the world works, you know, as a collective achievement, really is enhanced by having the understanding of those underlying mechanisms. And so it's the ideal, maybe it may not be advisable to aim for the ideal. In fact, you often is not in life, but the ideal is to have the complete story. However, there is one thing that makes it a little bit easier to have that complete story in any particular case is the selection principle that tells you, you know what, a whole lot of these details actually don't matter. Some of them do, but a whole lot don't. So that makes it easier, although I would say still in many cases, for practical purposes, impossible to be a complete understander of a lot of things. But fortunately, and you know, we should always have a fallback position in philosophy. Fortunately, there is partial understanding is often really satisfying. You can say to yourself, well, I wish I understood why, you know, things have mass or what gravity really is. I mean, probably we still don't understand what gravity really is because we haven't yet integrated Einstein's theory of relativity, the theory of gravity, with quantum mechanics. So we just don't understand it yet. But we do, of course, have a lot of very valuable understanding of gravity-powered phenomena. You know,
at the very least, in relation to our macroscopic experience of it, right?
Yeah, I mean, we have a lot of understanding of, you know, what's going on with the planet circling the sun and so on, or you know, some of us more than others, of course. And so it's not as if we're just left flapping in the wind, not understanding what gravity is all about. But I do think that when we have that understanding, in some sense, our understanding, even of macroscopic gravitational phenomena, the orbits of planets, the phone falling to the floor, and so on, will be more complete, will be richer.
And that seems almost inevitable, right? Like as fields tend to grow, they are going to splinter because that a division of labor is the most optimal way to grow the way that we do.
Yeah, yeah. And, you know, I get why you think, say you're doing a historical explanation. Why is it that the American Civil War broke out? it seems like quantum mechanics is completely irrelevant. It's certainly practically irrelevant. I don't disagree with that at all. But I do think that it's not only important to know that, humans were at work with their desires and their beliefs and their plans and their strategies and their hopes and their disappointments, although that, of course, is what people who work on this are mainly concerned with. It's that understanding the way that those minds work in terms of the neurons in the brain and ultimately the chemistry and physics of those neurons really does add a little bit to seeing how the whole thing happened. But that's to give you a sort of a sense of why so many philosophers would raise a bit of an eyebrow at that. They would be thinking, well, does it really help us? Are we really any more do we really have any more grasp of these political events by learning, even just understanding the way the mind is implemented by the brain, or does it just completely not matter? I can see why it's easy to get thinking, yeah, it doesn't matter in that way. But I just go back to thinking again, it does matter in the end how the collisions work, how gravity works, and so on. It's certainly not at the top of the agenda, but it's ultimately part of the story, and the story will be richer if it's in there, if we can explain why in a universe like ours it's even possible to have thinking beings like us.
Right, absolutely. I mean, like I can see why people might argue that it's practically not feasible.
Yeah, well, of course, and I'm not going to dispute that. That's
Right, of course. Yeah. But although there are people doing things like big history that are very interesting. Um, but I mean, in principle, it has to matter, right? Like, if take the case of history. If you're a historian who's trying to figure out what happened in the American Revolution or Civil War, um, what kind of questions do you ask? Do you ask questions about, or what kind of frame do you take? Do you think that everyone is sort of a tabula rasa that takes up their context, or does their physiology, their cognition, relatedly their biochemistry, and relatedly their physics matter? And I think if you're being honest, it has to.
yeah, that's what I think. So of course, we kind of take it for granted that all that stuff is in place and functioning, and these people who are the actors in these historical events. So in some sense, we're kind of officially bracketing that. But I think we are bracketing it that it's not that it ultimately doesn't matter at all. But we wouldn't want, on the whole, we wouldn't want our historians to start worrying about, never mind the quantum physics. We don't really even, it's just not where their expertise lies to start thinking um, about the reason that humans are the kinds of emotional, affective beings that we are, even though that certainly does have an impact on history. It's good that they bracket that and just kind of accept that we work in a certain way and don't try to kind of get into the amygdala or the any of that stuff. That's let different experts take care of that part of the story, even though it's, of course, it's they're there. You can begin to get a sense for why it's not irrelevant. While at the same time seeing that this division of labor is a good thing.
Do you think philosophers are the ones who try to fill that space? Or are we the ones who are crazy enough to try to conceptualize those questions and try to make them into their, not solve those problems in physics and in history, but try to create a new perspective that can bridge that gap?
So there's one job to do, is to knit together all these different separate understandings into a bigger story. And I think that's one thing that some philosophers are very good at. Also, some scientists are very good at it. 99.9% of what scientists do is not that, and I probably should have added some more nines. But at some point, when we have the ability to make these connections, we really want to make them. Of course, it can be challenging precisely because if you have people who spend their whole lives just working on one part of the story, it takes a certain you kind of need a dispensation from the university to step back in that way. One way to get that is to be a philosopher of science. It's kind of like your job. That's why some of the most interesting big picture stories about, say the evolution of music, something I've been reading about recently, have been philosophers have contributed a lot to them. Or a certain kind of scientist whose lab is up and running, maybe they're getting a bit later in their career, can perhaps have the leisure and not to mention the funding to step back and write about those things. And some popular writers, people whose main income is coming from writing books for general audiences, are also very good at this and do some valuable work. But it's a less institutionalized job than more specific researchers.
Okay, what about on the other end of reduction? So that those are sort of practical arguments around reduction. But what about the idea that there might be, at some level, genuine causality that pops up, that emerges? So you describe it often as the wedding cake ontology, that you have these primitives, and then so you have particles, and then you have aggregates of particles that make chemicals, and so on and so forth. Is it plausible that at any one level there is something that happens that isn't reducible to the level below in an explanatory way?
Well, I think so. I think no. I think it can all be made sense of at the bottom level. But my colleague in the broad sense and friend Nancy Cartwright thinks there's a sense in which that's just a sort of more like a religious faith than knowledge, and I think she has a point. So I think there's lots of. It's not as if we have no idea, but what we have is some extremely successful reductive stories where you can explain exactly why it is that the thing happened at the level of medium-sized objects, given the fundamental physics. So one of the very first cases of such a story is that I mentioned earlier is understanding the structure of the solar system. We can understand these planets, which are such complex objects, because gravity is in some sense such a simple phenomenon. We can understand what they're doing in terms of fundamental physics, and we don't have too much doubt as nobody much doubts that the fundamental physics is powering that process whereby very large objects move around in orbit one another or fall into one another's arms and so on. But Nancy would say, but this is really, actually, if you look at all of the phenomena in the world that are worth thinking about, let alone all of the phenomena in the world, that's just some tiny little percentage of them. And furthermore, a percentage, not unsurprisingly, that are especially amenable to analysis. And what we reductionists think is, well, it's like that, except more complicated for everything else. And what she thinks is, as it, why not think that? Why be so blasé about supposing that you can just perform do the same kinds of stories for more complicated things? Why isn't complexity itself the kind of additional feature of the situation that would make you think twice about making the inductive move from a few successes to the idea that it's in general it's going to work? And I know psychologically, at least, I don't know how good this is as an argument, but psychologically I understand why I believe this. It's because every time you sort of really, it seems like every time you get stuck into one of these problems, even though there are tremendous challenges to understanding, how say thought is realized in terms of electrons, protons, and neutrons, nevertheless, it seems that what typically does not happen is you don't run into mysterious causal processes that just don't seem in any way relatable to the next lowest level. It seems like everything turns out to kind of go along with the thought that it's the neurons are making it happen. If I mess with the neurons, I mess with thought. When thoughts change, and so far what's going on at the level of the neurons is changing in some way or other. Of course, I mean, our understanding of this is microscopic, but now, we don't know why that particular change is a change that is a difference in emotion, or reaching the opposite conclusion, concluding that it's not raining rather than it's raining. But we see the kinds of correlations between what's going on at one level of description and what's going on at another level of description that you would expect if everything at the higher level is a kind of a manifestation, is an orchestration of the lower level stuff. So I think that's what really persuades me that the reductionist principle is going to pan out.
Yeah, I mean, like history does end up being on the side of reduction, but maybe the defense for it is just that there is no principled reason to reject reduction.
There's more of a kind of a caution, a sort of a wait a minute, how much evidence do we really have about this? How well have we sampled the space? It's less of a positive argument against reduction, I think. The kind of argument people once thought they had in the case of things like life and consciousness and so on. I guess with consciousness still there are arguments. In a way, consciousness is a rather special case. But in the case of life, the kind of causal complexity that would have to be there to make life happen, but which you might have thought isn't there when you just look through a microscope at this sort of undifferentiated jelly, turned out, in fact, to be there in the jelly after all. And all of the kinds of complicated processes that a reductionist would expect to be there if life were something that could be explained ultimately physically, have in fact turned out. And again, we still only have 1% of the story, but we can kind of see the kinds of stories that we expect are there, with understanding that we now have of the way that genes are kind of all kind of genetic material generally is running the process of biological development. Again, there's so little in one sense we can say about it, but on the other sense, it's just sort of that you start drawing the arrows in the boxes, and it's the sort of thing you would expect to see if it's the molecules that ultimately making it happen. So that's the sort of encouragement that we keep getting over and over. I guess I should acknowledge my dualist colleagues here at NYU and say they have, there are positive arguments with some weight for thinking that even allowing for everything I've been talking about so far, the case of consciousness is going to be a special one that will resist reduction.
Yeah, like in the origins of life, I mean, the details aren't known yet, but I think everyone in the field seems to be convinced that there are all these approaches that are fruitful and will eventually work it out. But with consciousness, there are these people insist on the hard problem or move towards a new form of panpsychism and stuff like that. What do you think about those problems specifically?
Well, I think I'm a bit of I suppose I would classify myself as an amateur when it comes to the philosophy of consciousness in a certain sense. So on the one hand, we see the same kinds of encouraging signs I was just talking about that a reductionist looks for. It's when you have a difference in conscious experience, there's typically you can find a difference in what's going on in the physical material of the brain. So the philosophical case against reduction doesn't turn on denying that there are these very that there are the correlates of consciousness that you would expect in the same way you see the correlates of all the various other biological processes like biological development and that sort of ongoing life, and so on and so forth. It's more that there is this positive argument, well, I suppose it's more like a negative argument, but it's a positive negative argument that consciousness is just not the kind of thing that even could be explained through a material reduction. So by sympathy, I'm a reductionist, but I don't myself have any kind of clever defense against those arguments. I can cheer on the physicalists when they fight back against the anti-reductionists, but I'm more of a spectator on the sidelines there. I suppose maybe occasionally volunteering my help when it comes to issues about explanation. But this is probably one of the questions about explanation, where what I have to say about explanation and my is not going to be of any immediate help.
Right. No, I agree. I agree. I mean, like everything in me wants to accept a reductionist account. I just want a mechanism of what consciousness is, and I want to be able to play with that mechanism to make predictions. I can't imagine thinking a different way. But you're right. There are no good arguments. There are no good responses to the hard problem.
Or there are, there's good philosophical responses in the sense that they're kind of dialectically appropriate, but there isn't something where you kind of say, oh, I see, of course, why was I, in the same way that we have it for something like life. You can just say, just give me an aspect of life and I'll show you how it all pans out at the molecular level, or at least how we expect it to, but with consciousness. No.
Yes, agree. No, they're great responses, just not settled responses.
Yeah, it's really hard to see how, this of course is not my colleague Dave Chalmers' official argument for dualism, that he's made so much of the kind of conceivability of the zombie and so on, but it's connected, but in a way a different kind of concern that of course philosophers have been worrying about for ages. It's just really hard to see what an explanation of phenomenal consciousness could even look like, let alone how it could be done using the kinds of techniques that we have in for all of the rest of science.
Yeah, I don't even know how to begin talking about it, let alone.
Yeah. So one possibility is this. I mean, I think it could have turned out. Now I'm really going to sound like a philosopher, not a scientist. It could have turned out that there are several different basic levels of causation in the world. So something like the vitalist story about in biology would have turned out to be true. There are just certain, and exactly how it would work out, I'm not sure, but there could be certain kinds of stuff or certain kinds of properties that physical stuff that were sort of additional to the physical properties of physical stuff that kind of came along when physical stuff acquired a certain complexity. And those properties have as well as being kind of sui generis in themselves, have certain kinds of sui generis causal properties that can make things like life happen, that can sort of orchestrate processes with the kind of teleological character that someone like Aristotle thought could never be explained in physical terms. It could have been that way. I mean, except we do know now how to explain that all of that appearance of teleology in physical terms, whereas Aristotle still didn't have many of those explanatory maneuvers at his fingertips. But it could have turned out that that's just not the way it works. And likewise, maybe at the level of thought, not even putting aside consciousness, but just in terms of the connection of ideas, reasoning and thinking, reasoning, and so on, that there's again another basic level of causation there. And that again, it could be that the mind is built of physical stuff, but that physical stuff kind of acquires some additional properties that are not purely physical properties, that have certain causal connections. And then if story like this was true, then psychological explanations, biological explanations, and so on would still have been causal explanations, but there would have been multiple causal levels. There wouldn't have been one ultimate level to which we refer everything, the physical level. So I think actually our basic conception of explanation allows for that. It's turned out that we don't need the multiple levels, or at least we haven't needed them so far. Maybe now you can begin to see where I'm going with this. The physical level has done it all for us, but it could turn out that with this one thing, consciousness, we do need a different level, a second basic level. And some people might say, for moral realists might say, for normative properties, well, let's have a level there too. Maybe it's not causal in that case, but a separate explanatory level that generates its own explanations, that kind of connect to the world in some ways, but because it's happenings in the world have moral valence. Uh,
Yeah, the three things that always pop up in my mind with stuff like that is our moral judgments, aesthetic judgments, or math. The debate between Platonism and constructivist theories.
right, right. So you can start thinking about the moral issue as being a little bit like one of these emergentist stories. There are certain configurations of physical things that, as well as having physical properties, have moral properties, like a certain action of a of a of an agent is bad or good or whatever. And and then if you think also that you can have a certain kind of there's explanations in the moral domain, then maybe you can explain why some things are good or bad with reference to other moral properties. You know, a certain action is bad because it will bring about certain things that are bad in themselves, something like that. And so you can kind of have a whole other field of explanation that turns on these properties. Anyway, I kind of like I like to think about the potential open-endedness of the world of explanation. So although I'm on the one hand, one of my projects is to do everything with physics, if you like, with material. At the same time, I'm sort of intrigued by the idea that there might be many other kinds of explanation, and that it's not uh, all like scientific explanation.
Yeah, it seems to me there could be like there's a radical way and not so radical way to put that. I think one way is just it's emergent, but there's nothing ontologically mysterious about it. It's just that there's stuff that gathers around and creates something new. It might be you can't predict it. It might be a chaotic system, but it's emergent. But then I think when people often talk about morals or math, I think it's a great example. That's not what they mean. Like when people say math, when numbers are these platonic forms, it doesn't mean that they're constructed out of some sort of lower substance and then aggregates where you can't predict the aggregate behavior. It means that it is in its own sort of realm of existence, that it's somehow separate.
Yeah, yeah. So what in ethics you would call a sort of non-natural moralism, uh, and of course, as you say in math, Platonism. Mathematics is especially interesting for philosophers of science, of course, because mathematics seems to features so heavily, at least in our representations of the world. And there's a lot of good arguments about whether it is kind of, as it were, there in the world itself, helping things along, or just helping us to build pictures of the world.
Right. All interesting questions. Okay, on the other end of it, so putting forth this criteria of selection as an important criteria, people often read sort of relativism into it, that we're putting the observer at the center, that would be the objection in physics and so on. How do you respond to that kind of idea?
Oh, so on the one hand, you might think that there are that the standards for explanation themselves are kind of a human creation, or at least, if not kind of a active creation, sort of something that are distinctively human, and that on a different planet there might be a different race of intelligent beings who just simply had a different standard for picking out. Maybe it's just the way I say it is, except with a different selection principle. So it's still a matter of picking out the essential aspects of the causal story, except over there, on orbiting Betelgeuse, they count they have a somewhat different criterion for what counts as an essential standard, and there's no right or wrong. That's just the sort of thing that tickles their explanatory fancy. That's how they get understanding. That's one way. That's on the one hand, it could be the whole caboodle. The whole criterion for explanatory correctness is relative, in the sense that different um, traditions of empirical inquiry could have different ways of doing it. Or it could be that within our own human criteria, there are certain options, and which option you take is in some sense open to you, and an option that's good for one group might not be so good for the other group. So often when people say certain aspects of explanatory relevance are interest relative, I think this is what they have in mind. I think there's no question that given the complexity of many explanatory stories, that some parts of them are going to be more important to some groups of people in certain situations than others. So some kind of interest relativity comes into it. The question is how deep can it go? To what extent can we really have a kind of a clash as a result of this relativism? And to what extent is it just different people, in some sense, really just asking different questions and therefore getting different answers? So, maybe it was, so I'm just thinking, was it Collingwood, who, although he was kind of riffing off Mill, was discussing what's called causal selection. We sort of, different groups of people will pick out maybe something different as the cause. And it was maybe Collingwood who mentioned the case of a car accident where the highway engineer, the question is, what was it about the construction of the road that caused the accident? Whereas for someone else, it's for the legal department, it's the intoxication of the driver that really matters. And then maybe for the automobile engineer, it's the car itself. And so it's not as if, but they don't really, it's not like they really disagree that all of these were factors in the accident. It's just that each of them throws a spotlight on a different part of the story because they have certain professional interests and responsibilities. And there it really seems like there's nothing, they can all agree on there being an objective matter of fact about what's relevant, on there being a selection principle that tells you in principle what's important and what's not, and then also agree to sort of divide up the work of thinking about different aspects of the story in the same way that the scientists are dividing things into different levels. But could it be that because of something about your kind of epistemic context or goals, you pick out some aspect of a story as being explanatorily correct in a way that, in the same way as when people think about moral relativism, it sort of seems like you've gotten it right and these other people have gotten it wrong. Meanwhile, they're thinking they've gotten it right and you've gotten it wrong, and actually there's no fact in the matter. Can we have that kind of relativism in our own human explanatory practice? That's it. There you don't have to travel to another planet to answer the question. You can kind of look at people. I mean, there's plenty of vociferous arguments about explanation going on. Do any of them actually turn on a difference in standards for explanation or a difference in the way the standards are being applied? Or are they really disagreements about what's going on? or alternatively, they're disagreements that when you look more closely aren't really disagreements at all. It's more a case of why don't you people just do your thing and you people do your thing and benefit from both parts of the story. I don't see a whole lot of evidence in science for there being a genuine difference in standards, where you would expect just a kind of impasse, like where the kind of impasse you get in the moral side of the story, where some people say, no, it's just abortion is at any time is just wrong. No, it's absolutely women should have the right to abort it at least for a certain amount of time. And that really seems like a genuine difference that's not going to resolve itself. It's not like people are just asking slightly different questions. They are genuinely giving different answers to the same question. I just do not see those kinds of arguments really happening in explanation, even in case, it's either a genuine difference in sort of what's going on causally. One group thinks it's really, this stuff doesn't matter so much. To give you a somewhat concrete example, there's a thing called the sort of the neutral approach to modeling in ecology. I don't know if you know anything about this, where I'm sure people, not everyone watching will, where you kind of ignore the different, in order to understand the structure of an ecosystem, the way that the different species have different kinds of footholds, there's more of this one and a few of this one, and so on. You ignore all the differences between the species, in particular the ways that one species might be more adapted to the ecosystem to another, and approach everything at a much more abstract level. So that's like saying a lot of stuff that looks like it's really causally relevant here, you know, that this organism is just much more of a general purpose feeder. A lot of more things count as food than for this organism or something like that. Well, maybe that's one of the things that neutral theory people do care about. You know, of course, well, it's not monolithic anyway. But just to give an example, you might either pay attention, you might say, that actually turns out not to matter so much. We can understand why these systems have the structure they do independently of looking at the details of the things that fill that structure. But I think with something like that, you might think, is this a difference in standards? Some people just are happy with a much more abstract explanation that maybe makes sense of less. I think with those kinds of, if you look at those kinds of disagreements, it turns out usually that one group is trying to explain something a little bit more abstract, and the other group really wants to have an explanation of a bit more than just that very abstract thing, like just some very abstract level of the structure in the ecosystem. And also, usually at the same time, they do disagree on whether certain things are actually important, even to the abstract thing or not. But what there isn't is a real difference in kind of explanatory standards. That's my impression anyway. I know I can find some philosophers to take the other side of this argument, but
no, that makes sense. I mean, if you sneak in beauty or simplicity as a explanatory standard on top of whatever selection criteria you might need.
Well, I see relatively little of that actually. So even though we may agree that a simpler, or there's a certain kind of elegance to a certain explanation and not to another, or maybe we disagree and I think it's elegant and you think it's not. I think that those kinds of disagreements actually do not give rise to arguments in the scientific literature about which explanations are right and which are wrong. So, you know, there are disagreements to be sure, but they don't seem to be disagreements that bear on ultimate judgments about explanatory correctness. That's my impression.
Right. I mean, because to go from a philosophical conception of explanation to the actual scientific enterprise, there are rules and things that occur in the enterprise that constrain how inquiry is done as well.
Yeah. And it seems that the rules for having a good explanation are rules that are understood pretty much the same way by at least by all the scientists working today in our kind of what would you call it? Well, I mean, now science is so globalized now, it's just science. And I would add that it's been pretty much that way since the beginning of modern science and the scientific revolution, although not before then, but since. And so there's a pretty common understanding of what a good scientific explanation is for the purpose of kind of publishing scientific explanations, even as there still may be various kinds of disagreements about the aesthetic or philosophical or religious merits of various kinds of explanations, you know, the spiritual implications, if you like. Nevertheless, that is kept outside of arguments about what the right and wrong explanations are of whatever the phenomena are in the various parts of science. So it's a system that has found a real kind of normative common ground.
Right. Okay. So to get into your book, what changes in the scientific revolution that makes science the way that it is today?
Well, I think that an important aspect of the scientific revolution was precisely putting some of these disagreements aside. So saying, essentially, discarding a long, thousands of years long tradition of doing the philosophy of nature philosophically as well as empirically. So that means two things. One of them has to do with what the standards for a correct explanation are, and one of them has to do for the standards for deciding what the evidence or which explanations we have good, better, or worse reason to believe. So I'll start with the first of those, which is not what I was just telling about. So, it's still the case that many scientists are religious, and certainly historically, many scientists have had strong religious commitments that have impinged on their subject matter, where taking their religious beliefs seriously would have inclined them towards or away from, not definitively, but just to some degree before and away from certain kinds of stories. So the case of biology and the origin of biological diversity is, of course, the most famous, maybe the best case, but also the biology of life and so on is I think another good case, maybe thought to. But in effect, in the scientific revolution, as I see it, some people partly under the influence of British empiricism, partly under the influence of Newton, although he was British, was less of a philosophical empiricist and more of just a kind of an interesting character. Maybe I shouldn't say any more about him just yet, but found a way of doing science where they just pushed aside, agreed that we were that religious belief can be a very important and motivating force in life, but found a way to exclude it from scientific argument. So we scientists may look with great doubt on certain kinds of explanations. We may, as a committed Christian, I may think I have good reason to reject the Darwinian story about the origin of species. Or alternatively, as a militant atheist, I may feel like I have really good reason to accept it because it's just what I was looking for all along. But we both agree that we're not going to bring that into our argument. So we're just going to evaluate theories empirically. So that's one part of it that has nothing specifically to do with explanation. Is this pushing the aesthetic, the philosophical, the theological, if you like, or religious elements out of the argument and just thinking in empirical terms, in terms of what the evidence is showing you. The other part of it was agreeing to precisely this relatively shallow, as I call it in my book on this topic, Knowledge Machine, relatively shallow conception of explanatory goodness, where things like beauty and elegance and so on simply are not built into our standards for explanatory goodness. So we may ourselves, it's not as if the science as a human being or even as a kind of inquiring mind has to in their own personal life follow these rules. It's more rules for the conduct of public scientific argument. In their own mind, the scientists can think that explanation can't be right. It's too ugly. Actually, I'm getting a little bit back to the reasons to accept and reject, but I think that's okay. Let me run with that example for just a few more sentences. They can think that in their own mind, but what they can't do is discuss that sort of consideration in a scientific journal and say, I have evaluated the current contenders for theories of quantum gravity in terms of their aesthetic merits, and I've given them all scores out of 100, and this is going to help us decide which are the more plausible and the less plausible theories, where, of course, the theories scoring more highly are the more plausible ones. You're only allowed to bring the evidence into play. And then, at the same time, of course, you are looking for good explanations as opposed to bad explanations. The goodness of an explanation doesn't turn on things like elegance. It only turns on what we started talking about, which is the question of what you would need to write down about the causal story to be able to deduce that the thing you're trying to explain happened. So in other words, a criterion that just turns on the facts about the causal story to be established empirically, and at least in my telling, this selection principle, which just really turns on deductive logic, therefore on something that's not colored in any way by considerations of beauty or harmony with some kind of spiritual beliefs or philosophical beliefs, harmony with a kind of philosophical system, or anything like that. And so we're able as scientists to kind of get along and operate within what is in some ways a narrow framework, but a framework that, because it's well established, gives us a very solid ground on which to actually move forward in using the one thing we are allowed to use, the observational data, to figure out what's right and what's wrong.
Right. I mean, that's absolutely true. There is a huge disparity between the private public lives of scientists and what they publish and present at conferences. I mean, everyone has these large curiosities. Maybe not everyone. Some people are just like data, but everyone has interest and leanings in one way or another, or is impressioned by something that they're working towards. But it is a great act of labor to push that down and keep it out of your scientific work.
Yes, and I think it's been rather neglected in the philosophy of science, actually, this big divide. Probably by default, philosophers have focused on what goes into the individual deliberations. In a way, that's, of course, the individual epistemology has been at the center of Western philosophy, at least since the early modern period, and philosophy of science has sort of gone along with that, even while trying to accommodate the institutional structure of science. But on the whole, I think philosophers of science, even those who are working on confirmation theory and so on, have attended more to what's more like the deliberations of the individual than the kinds of things that actually make it into the scientific literature. And so there's been relatively little comment on that side of science. If people, it took me a while to twig to this myself. I would read scientific papers and they would say at the end something like the evidence is consistent with the hypothesis that we favor. And I would kind of laugh and think, yeah, that's kind of funny that you put it in this absurdly weak way. The evidence is consistent. The contents of my desk drawer are consistent with your theory, but hardly worth publishing in the scientific journal. Of course, that's not really what you mean. But over time, I came to see there was a reason that it was being put this way. I mean, there's more. That's especially weak. But there's something to be learned about the way science works and the kind of very, very weak claims that scientists will make about their evidence and their published work, even as you know that they are thinking about it in a much stronger way in their own private lives. And I like, one of the things I wanted to do with this book. This book I wrote as a general audience book, so not just for philosophers, but I do hope that philosophers who read it will start thinking more about the significance of the difference between the way that public scientific argument works and what I mean by that is what's in the journals basically, or in conference papers, and the kinds of and I suppose how scientists think. What's happening in the public sphere doesn't really capture any kind of reasonable train of thought that a rational human being would have, because it's so because certain considerations have been put aside, not because they're irrelevant, and logically, but just for a kind of institutional reasons to kind of to find a shared basis for going forward with inquiry. So maybe not every scientist, but many scientists will in their publication be telling a story which leaves out things that they think are really important. That's a story that they would be that is simply doesn't reflect what they take to be the complete story, bringing in all relevant considerations, therefore a story that violates what Carnap and other philosophers called the principle of total evidence, that says everything that's important has to be brought in, unless some kind of cost-benefit consideration makes it just impractical. You should consider everything important before making up your mind. Science is built on almost on the precept that we're not going to consider everything that we consider important, but just the things where we can find a certain kind of common ground that I think many, a philosopher like Aristotle or even Descartes, working before modern science really showed how successful it would be, would look at that proposal and quite reasonably think, that's not going to work. I mean, sure, you get the common ground, but so you have agreement, but it's just too narrow to make progress without the big picture. Of course you'll come up with some stuff, but you're not really going to figure out how gravity works. And it's turned out to be almost exactly the other way around. It's the philosophy that gets in the way of figuring out how gravity works, and the kind of this narrow, unphilosophical focus on getting the details right has turned out to be what's really opened the doors to a whole new conceptions of these things. Who could have anticipated that? I don't think anyone knew it would work that way. Not even Newton, who really was who, in some sense, Newton showed people that for the first time it could work that way. But I don't think even he realized at first that he was operating. I don't think he thought of it as being the way that science should be done. He thought of it as the way I'm going to do my mathematical physics. But I don't think even he would have prescribed it as the right framework for all natural philosophy.
Yeah, I mean, it's a perplexing question why it happens with Galileo and like not with Aristotle, because you can see, I mean, the beginnings of empirical methodology with Aristotle, or at least the potential for the beginnings of empirical methodology. But I mean, Aristotle would have hated the idea that ignore all the conceptual questions.
Yeah, I mean, even with Galileo, you see, especially in his later work, you see the probably more than just about anywhere else. I suppose in Huygens a bit too. Although I guess I'm trying to think, he's sort of a little bit before Newton, I suppose. You kind of see the Newtonian idea working out in some ways, but someone like Galileo is also philosophizing, especially in the dialogues on two-world systems. So he's doing, he's kind of hedging his bets. He's trying it out this way and trying it out this way. Newton too hedged his bets, as we know from looking at his private papers. But in the Principia, when he set it all out, he just left all of that stuff out and just presented the empirical case with this, as I call it, the shallow conception of explanation that says, doesn't matter. It's okay not to worry about how gravity works. We don't have to. We shouldn't be worrying at this point about whether the idea of action at a distance is even philosophically coherent. Let's just see if we can frame some principles, that in the laws of motion and the force laws, that will get the phenomena right. That's my enterprise. And as I say, that you might have thought that was a very restricted project that would be useful in some ways in physics, and not so useful in other ways, but it's turned out to be the blueprint for all of modern science and physics and everything else.
Do you think the principle gets, like the principle of focusing on just evidence, gets more muddy as you progress into the special sciences or into higher level sciences? That once you get past economics, for example, then questions become so complex and there's so many variables that methodology becomes less attractive. I'm not sort of endorsing that view. Just,
well, I mean, it's a really good question. I mean, once you understand how artificial scientific methodology is, I think, then of course, and talk a little bit about, how could you have anticipated that it would work so well? That of course raises the question, well, maybe it doesn't work so well for everything. We've been plucking the fruit that we can reach from this particular ladder, but other fruit is just totally out of reach from this ladder, and what we need is something completely different. As a matter of fact, I think the special sciences and even the human sciences have modeled themselves on the Newtonian model in some sense, not in every sense, but in the senses I lay out in the book, and staying empirical and building causal models and not uh, 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 not philosophizing too much. Um, it's not. It's a little bit more complicated than that because in some cases you have aspects of the social sciences that are often thought of as the humanistic social sciences that have kind of reserved the right not to proceed that way. Like a certain amount of cultural anthropology, for example, is like that. History is still, I think, largely not regulated by the rules of science, even though some historians would like to do it that way. Um, so there is room in the study of society for for work that's conducted in a way that isn't doesn't fall under what I call the iron rule, the rule that the empirical evidence only rule. It's not obvious though that the progress is being made in those areas that couldn't have been made under the iron rule. I mean, which is not to say that they don't have certain advantages, but it's not obvious that they're, as it were, picking fruit from a completely different part of the tree. So in that sense, it's hard to know really whether there's another way of doing things that could be really deeply different. There is another way of doing things for sure, which is even just the old way of doing things, the way Aristotle did things, for example, and it has its virtues, but it doesn't seem to really give us access, at least so far as we can tell, to things that to whole new kinds of explanations, like an explanation for consciousness, for example. So I'd say that it's good to keep an open mind about that, but right now we don't have much reason to deviate too much from, in most cases, from the standard scientific ways of doing things. I mean, I think we should. That's not to say we shouldn't be experimenting with other ways of thinking. Of course, I think that's good, but there isn't some obvious place to go. There isn't some other there's not some other game plan we could just start exploring right now.
Right. And sometimes perhaps it doesn't have to be as prohibitive as we think when it comes to the human sciences. That although the iron rule excludes thinking about, say, normative judgments, it doesn't exclude asking whether something about making a normative judgment could be empirically tested, right? Converting like a question that may be of normative significance or philosophical significance to something that could be tested, to something that could be understood in terms of its underlying mechanisms.
Right. I mean, yeah. Yeah, of course, there are lots of ways into normativity that are quite scientific, one way or another. Um, uh, but yeah, maybe it's better not to not to go too far, too much. Better for me anyway, not to go too much further afield than that. But I think there's a lot of life left in the empirical only model. And I certainly, I'm someone who thinks that the subject matter of science is not limited. There's, in principle, actually, to take in some ways what's actually an easier case to discuss, but in a similar vein, there's can be such a thing as empirical theology. So, maybe we live in a universe where it's not going to turn up much. If there just is no God, or if God really is completely hands off, empirical theology is not going to get very far. But there's in a universe with a different kind of God who's leaving all sorts of little Easter eggs scattered around, or has a big plan that works, that leaves definite signs and things. There is, as the natural theologians thought, there would be a purely empirical pursuit of theological knowledge that would be possible. And I don't think that would be unscientific, because I don't think there's some prescription on the, as I say, the subject matter, the fact that you're talking about God or some spiritual entity or consciousness, or for that matter, norms in itself doesn't rule your hypothesis out of court. what is needed is for there to be some connection to things that can be observed, since that's the only kind of information you're allowed to use to argue for and against your hypothesis. So you do need that kind of connection. But if there is that kind of connection, I would count that as scientific.
Right, that's true. As long as it's compatible with the iron rule, then it's science.
Well, that's my I guess that's my kind of quite strong view of what science is. Yeah, strong in the sense that it sort of has some rather strong implications.
What are those implications?
Well, the one I just gave you. I mean, I think many people are certainly tempted by the idea that the subject matter of science shouldn't go outside the natural. So it's got to be, in some sense, material stuff. And I can kind of see why they say that. There are certain philosophical problems with that view, because it seems like in that case, to get going, you have to have some sense of what material stuff is. But the best information about that comes from doing some science. I suppose maybe there's a sort of bootstrapping you could do, a couple of thousand years of philosophy to get a conception of what's natural and what's supernatural, and then you can start science going once you have a bit more of a sense of what's natural. But I think in fact, and in a way, this is I don't know, like all of these views. Is it on one hand, it comes from looking at what it's a matter of just seeing what the rules are for in scientific discourse, but probably every time a philosopher does that, they can't help being a little bit prescriptive. So there's a little bit of sort of me sort of cleaning things up to what seems to me like an interesting set of rules. But I do think it actually fits the way that scientific discourse is adjudicated by the whole apparatus of journal refereeing and editing and so on. I think it fits that pretty well.
Right. Okay, makes sense. Okay, what about the social structure of science itself?
So we've been talking about, of course, about one aspect of that, the side of the social structure that's, I suppose you could say, epistemic. So it's about what kinds of arguments you can make and what you can't. But I've also done some work on the motivational side of the social structure of science, so how scientists are rewarded for their discoveries, and that's maybe what you're inviting me to say something about.
Yes. Yeah.
Okay. Yeah. So I think this is a topic that has been around since the beginning of the sociology of science. It's a topic that Robert Merton, one of the founders of the sociology of science, I think wrote about in a pretty interesting way, and has been, and a topic that's also of great interest to scientists themselves, of course, is the rewards that they're angling for. And one thing that Merton said, and that many scientists have found themselves much in sympathy with, is the idea that there is a kind of distinctive reward structure that in which the currency is not money or anything more material, but fame or status. And fame at every level. So the sense in which you can be famous among the 50 people who work on a question, not worldwide fame, but just a certain kind of status or prestige. Something like this is actually really quite important to many scientists in their work. And at least in some of my work, I've pursued the idea, inspired by Merton and by the more recent work of Philip Kitcher and a few other people, that pursued the idea: to what extent could we understand science as just purely driven by this sort of motivation? So of course it's not the case that human beings are purely driven by anything, but what interesting insights would come out of thinking of the if you like, the credit system in science as a system, as some kind of sociological technology, if you like, for systematically allocating credit. We could look more closely at how it works. We can look at particular that aspect of it that Merton and others have called the priority rule, where the first scientist to make a discovery gets all the credit for that discovery. If some other group are almost there, they get nothing. It's kind of like the second prize in science is nothing, which seems rather brutal. They've put all this work in, they've been working on some question of great interest. They've been making a contribution, and in one sense of making a contribution, really helping out. And then they don't get anything if some other group manages to publish first. And scientists themselves are very much aware of this, the priority rule in their lives, of the danger of being scooped, of losing out on a lot of credit for the work they've done in this way. So it's really certainly does figure in a big way in scientists' own thinking. In this sense, it does seem like there's got to be something interesting to say about the role of credit in science, and of the way it's dished out in particular. Why don't we give scientists credit in proportion to the amount of effort they put in? Sometimes one comparison I sometimes use is you're looking for something that's been lost. Maybe you're looking, a child is lost in the forest, and you sort of divide up the different areas of the forest and go searching for the child. And some people are looking in the wrong place. Somebody who has the right assignment will come across the child, but we wouldn't say, "That's great, you did such a wonderful job," and then say to everyone else, "Thanks for nothing." We would say, "It's great, everyone contributed, and everyone deserves credit and for a successful outcome." But that's not the way that science works. It really is kind of the thanks for nothing. It's like you get the glory for making the discovery, and everyone else who was trying and didn't get there, maybe just through bad luck, because you happened to be trying out a method that wasn't the right method, but nobody couldn't have known. Still, you get nothing. I mean, you get your salary. Maybe you made some incidental discoveries along the way. You get credit for those, but you don't get credit for the big thing. That question in particular, it's really interesting to ask why the system works that way. What could there be any advantage to such a winner-takes-all structure to the credit system? And so a part of my work is trying to argue that actually creates some motivational pressures on scientists. For example, when they're kind of hedging their bets a bit, when they're being a little bit kind of risk averse, that will actually push them in the decisions they make about which projects to take on. That will actually work out best for society as a whole, in the sense that they'll come closer to kind of finding the best possible allocation of scientists to projects. And this is a kind of a surprising result. You wouldn't necessarily expect that, but it does seem that the brutality of the winner-takes-all system molds the motivational structure in such a way that scientists will be a little bit more reluctant to take certain kinds of risks, where they could end up just being totally scooped and ending up with nothing but a kind of desk full of useless research. That actually turns out to benefit everybody, in the sense that it maximizes the chance of finding the lost child, or the structure of the DNA molecule, or the true nature of gravity, or whatever it is they're looking for.
Right. If there weren't these incentives, then everyone would go into the part of the forest that's the most beautiful, or the most attractive, or the most whatever reason that you have to go into it. You wouldn't have this even distribution.
Yeah, I mean, it takes a bit of mathematics to show that the winner takes all thing in particular is helpful. But one thing that's, as you say, that you can that seems clear without any mathematics at all, is that by giving scientists credit for discoveries and giving them more credit for more important discoveries, you give them an incentive to spend their time doing things that are more likely to be interesting and valuable, either intellectually interesting or perhaps medically valuable in the case of vaccines, cures for diseases, and so on, and therefore things that are actually not only going to fill the scientist's time with kind of with give them something to do, but things that are actually going to have some payoff for the world at large. That's kind of interesting to think of the credit system as even kind of in some ways engineered to do exactly that. I mean, as far as I can tell, nobody ever came together and said, let's set up the system in this way to have these outcomes. Although there are people right now saying, let's re-examine the credit system because we're worried that it may be having some pathological outcomes. But the whole thing kind of got going without any conscious planning, just sort of responding to what seemed intuitively right. Oh, you made this great discovery. You're a great scientist. We doff our hat to you, and so on. Somehow that became the kind of system, maybe not exactly the right kind of system, but the kind of system that encouraged scientists to work on the right kinds of questions.
Right. It's just our internal motivations and vanity, or whatever you want to call it, positive or negative, that lead to, that might be brutal for the experience of doing it, but lead to good for the society.
I mean, we have it in some sense as a kind of a big credit system. So I kind of speculated when I write about this stuff that's not just for science, but for everything. And, that we the adulation we give to the people who write the catchiest songs encourages people to write catchy songs. And that's that yeah, you can make a lot of money that way as well. So it's not just, you're not just doing it to be famous, but I think a lot of humans care as much about the fame as the money.
Do you think there'll ever be a situation where we'll sort of try to take hold of that process that's happening on its own and maybe consciously direct it so that it benefits society better, and also treats the people in the system better?
Yeah, well, so recently there's been a fair amount of discussion among scientists and science administrators and philosophers to an extent, but actually even more to people involved in this, journal editors, about ways in which the system, even if it obviously is better than a lot of other systems, nevertheless could be improved. So one worry is that the same winner takes all aspect encourages people to rush into print, to kind of get their results into print as soon as possible, even before they've done all the due diligence that they should be doing, just to make sure that they don't get beaten out. And I think it certainly is worth worrying about that sort of thing. I think actually a student of mine, Remco Heesen, has done some work on this, suggesting that in fact there is something suboptimal about the incentive scientists are given in terms of decisions about when to publish. So I've made an argument that it could be that the system it's probably not literally optimal in the sense of being the best of all possible worlds, but that it could be close, maybe among systems that could practically be implemented. It could be the very best system for in terms of getting scientists to make the socially most best choices about what to work on. But those aren't the only choices making. It could be at the same time not the best system in terms of encouraging incentivize in terms of the incentives that give scientists about when to publish the work that they've chosen to do. So it could be that it's good along one, could even be perfect along one dimension and really quite imperfect along another dimension. Well, then you have, of course, it's not so easy in a case like this to decide what to do. To what extent, what are we going to lose if we make a certain kind of change? So I think it's important to understand therefore it's important, of course, to understand ways in which the current system works really well as often the flaws are more obvious than the benefits, I think. So we should be cautious, but that's not to say that the flaws are not real and that we shouldn't be thinking about what to do about them. So I think this has come up partly because there's been just there's a lot of pressure now. I mean, it's never been easy to be a scientist, actually, but there's really is a lot of pressure in terms of getting funding and so on scientists. And so there's perhaps more pressure than there used to be to game the system. And any system like this, which is sort of, as it were, is a system of carrots and sticks that are separate from the thing that ultimately matters, pretty much any system like that can be gamed. There's never going to be a perfect alignment of stick and the thing that you really don't want, and carrot and the thing that you really do want. And so you have to be looking out for that. And I think always on the move, always changing things up a little bit to thwart the most obvious gamesters. And so it's good that these conversations are happening. Nevertheless, it might still be the case that we should stick with. I think probably I would be conservative here. Stick with the winner takes all, the basic winner takes all ideal, even as we tweak other kinds of aspects of the whole system of publication and peer review and so on.
Yeah. Maybe scientists are better off just being more emotionally stable and sort of not basing your whole life on your accomplishments, to rather than thinking that winner takes all can be overturned as a way of holding on to sanity.
Yeah, well, that's with everything in life. You can't. It's trying to run everything from the top is, of course, hopeless. No, it's just too complicated of a problem. So what you want to do is set up a kind of a institution where encourages people to make all the right decisions for themselves. But at the same time, as we know so well, as I was just saying, any system like that will have its problems, can be gamed, and so on. So there has to be a certain amount of policing, and it's a very complicated question exactly how much policing to do and how to do it and where to do it, and what shortfalls, what suboptimalities, what unfortunate consequences, just to kind of eat as the inevitable price of having a system that works well in other ways. So this is it's an instance of that much more general property about how to set up a society that works well.